Hello there. In this video we will take a look at counter mode encryption, also known as CTR. CTR is a block cipher mode of operation algorithm that uses a block cipher to provide information security. Unlike any other modes, CTR uses a set of input blocks, called counters. Each counter is equal to the plaintext block size. Each counter is incremented by 1. This is the simplest and most popular choice being used. However, you can choose to increment each counter by a constant value. Now let us see how CTR works. For this demonstration, we will choose the encryption method called DES, also known as Data Encryption Standard. DES requires 64 bits for both input block size and key size. Let's say we have a plaintext of 150 bits. The 150 bits of plaintext will be divided into 64 bits, which would result in two whole 64 bits block, and a partial block with 22 bits. Unlike other block cipher mode, CTR does not need any padding. We will explain this further in this video. While CTR divides the plaintext into blocks of plaintext, it can also generate a random nonce at the same time. A nonce means number used only once. The nonce has a length of the input block size of the encryption method chosen. For our example, which we are using DES encryption method, the nonce length would be 64 bits. This nonce value is used as the initial counter value. CTR will then use this counter value as the first input block for the chosen encryption method. With the key size of 64 bits entered, an output of 64 bits is produced. This output is then XORed with the first plaintext block. This will produce the first ciphertext block for CTR. For the next encryption iteration, the previous counter value will be incremented by 1. For this video, we assume the incremental value is 1. However, you can choose to increment it by a constant value, I, where I is a set of natural numbers. Now this new counter value, which had been incremented, will be used as the input block for the encryption method. The output of this block will again be XORed with the next plaintext block to produce the next ciphertext block. This step will be repeated for n blocks of the plaintext. For every n block, which is a set of natural numbers, the counter will increment by 1 or by a constant value, k. For this video, we have assumed that the constant value to be incremented is 1. Therefore, k equals to 1. This counter will then be used as the input block for the encryption method to produce an output block, which then will be XORed with plaintext n to produce ciphertext n. We still have 22 bits left to encrypt. Unlike other modes, CTR does not need any padding. The next counter is used as input block for the encryption method again. This will produce 64 bits of output. However, only the most significant 22 bits of the output will be used to XOR with the 22 bits plain text. The remaining bits, which is 64 minus 22, equals 44 bits, will be discarded. Now, these 22 bits of output will be XORed with the 22 bits plain text block. Finally, the length of the ciphertext for this last block will be 22 bits long. This concludes the encryption process. Now let's see how we would decrypt from a CTR mode. Decryption on a CTR mode is fairly simple. Let's use the block ciphertexts that we have made earlier as an example. CTR mode will generate a nonce value, with the size of the required input block of the decryption method, which will be used as the initial counter value. This counter value will be used as an input block for the choice of decryption method. We will use DES as our decryption method. With the 64 bits key entered, an output block of 64 bits is generated. This output block will then be XORed with the first ciphertext block. The result of this XORed operation will generate the plaintext block. For the second decryption onwards, the counter value will be incremented by 1, or a constant value chosen. For this video demonstration, we have chose to increment the counter value by 1. This counter value will then be used as an input block for the decryption method. The output will then be XORed with the next ciphertext block. This cycle repeats for n blocks of ciphertext. For the last ciphertext block, if the ciphertext block is less than the required block size for the decryption method, the most significant bits U of the last output block are used for the XORed operation, where U is the size of the partial block bits of the ciphertext, which is 22 bits. The remaining block size minus U bits are discarded. Now, the 22 bits of output block is used to XORed with the 22 bits ciphertext block to produce the last 22 bits of plaintext block. Therefore, this concludes the decryption process of CTR. Thank you for watching.